Hi there. So before I get started, I want to talk a second about Seymour Papert's book, Mindstorm. It has this subtitle all about logo, how it was invented, and how it works. Mindstorms, Children, Computers, and Powerful Ideas, and here by Seymour Papert. This is a 1980 book, but this is considered by many to be the Bible of computational thinking. And one thing I wanted to talk about before we got started that I think puzzled a lot of people was Papert's interest in Piaget. So, just right on the first page here of chapter one, he talks about Piaget. He worked with him. After 5 years, he came away for the Center for Genetic Epistemology in Geneva. And he came away impressed with Piaget's way of looking at children of active builders of their own intellectual structure. So that is key. That is his key, like, positive idea that that intellectual structure is built by the learner rather than taught by the teacher explicitly. So again, the student in Piaget's thought is constructing his own learning rather than the teacher doing that with direct instruction. And this came up in class a lot, and I just wanted to talk about it real quick. So Piaget, in boiling this down kind of very simply, in terms of developmental psychology, has this theory of 4 stages of cognitive development. So for children from 0 to 2 years old, they're in this sensory motor stage. So the first part of this word, sensor, means, right, my eyes, my mouth, my ears, my nose. The child at this age is gonna use those things to explore the world. And right, everybody you've ever seen, babies are always sticking stuff in their mouth. Anything they can do to kind of figure out the environment that they're in. The motor part is they're moving their bodies, they're figuring out how to move themselves in space. I think even though this is Piaget's like work here, I think like this idea of how the child constructs their own learning, like obviously nobody teaches a baby anything explicitly. The baby like figures out all of this amazing stuff on its own, and I think that's a key idea that Papert takes from this. At this stage, object permanence is a big deal. So in other words, if you show a child at this age a ball and then hide the ball, it will be as though it disappeared. I feel like this is why the game Peekaboo might work. Again, so from 2 to 7 years, roughly, there's what's called a pre-operational stage where the child can engage in pretend play. The child at this stage is often seen as very egocentric, meaning an example in some of my research was like a 5-year-old, you might be watching a movie together or a show, and the 5-year-old sits in front of you, and then you can't see the show at all, and they're not thinking of you. And Piaget would say that that's a developmental thing, that they haven't developed that reasoning yet. Okay, then from 7 to 11, they call this the concrete operational stage. There's a famous test that Piaget does to sort of see, that it's tough still at this stage, where I've got 2 equal-looking cups of water, equal-sized cups, filled up the same way, and then I pour them into 2 cups like this, and then the child will tell you that this cup has more water than the other. So that's like at that stage that this idea is starting to develop. Okay, then finally at 12 plus years, we've got the formal operational stage where we're capable of abstract reasoning, higher mathematics, and then higher levels of moral reasoning. So what is Papert's deal with this? And Mindstorms now, and Papert states, I've spoken of mathematics being learned in a new way, but much more is affected than mathematics. One can get an idea of the extent of what has changed by examining another of Piaget's ideas. Piaget distinguishes between concrete thinking and formal thinking. So Papert here is talking about those stages that I just showed you. Concrete thinking is already well on its way by the time the child enters the first grade at age 6. And formal thinking does not develop until the child is almost twice as old. Blah, blah, blah. Okay, some students, it is claimed, never fully achieve formal thinking. And now Papert doesn't like this. Says, I do not fully accept these distinctions. Even though they're useful, it's not as though they're not. And anybody that works with kids at all can see that they do make a kind of sense. Okay, nonetheless, I think what Papert wants to stress is that with the advent of the personal computer here in the 80s, there's a chance to create, to manipulate the context of the learner by being able to make special types of objects like scratch blocks or logic gates or light turtles or floor turtles that are objects to think with that are so rich that they can move that student through those stages from that concrete to the formal more quickly than would be possible. In other words, it doesn't necessarily have to be a developmental thing that is like permanent and based on your brain development. So seen in this light, these micro worlds are not another just powerful educational tool. They allow us to overcome like what has been seen as this boundary in child development. That knowledge that was accessible only through formal processes, in other words, by direct instruction from the teacher, can now be discovered from concrete activities. In other words, I can make things with my scratch blocks or my Dynaturtles and discover their properties by doing concrete things with them. That's how I discover how they work. I'm able to build more complex structures with them, build up towards abstraction, and maybe become a formal thinker, when we didn't think I normally could. Page 23 now, and Papert's talking about, I began to see how children who had learned to program computers could use very concrete computer models to think about their own thinking. So that's another key Papert idea, is that by programming this turtle, by relating to it with their bodies, that gives them a chance to, they're going to have errors, they're going to have bugs, they're going to move beyond the standard school model of either true or false, you either got it or you got it wrong. They're going to pay more attention to their process. They're going to think about their own thinking. And this is a great passage here. Learning to be a master programmer is learning to become highly skilled at isolating and correcting bugs, the parts that keep the program from working. The question to ask about the program is not whether it is right or wrong, but if it is fixable. And if this way of looking at intellectual products were generalized to how the culture thinks about knowledge and its acquisition, we might all be less intimidated by our fears of being wrong. So the micro world objects are the objects to think with. The new technology of the personal computer is something, according to Papert, that makes that possible. And you can use debugging definitely in contexts that aren't specifically with computers, but they allow education people to develop particularly rich environments for heuristic thinking. That's what Papert would say. In other words, for this kind of learning by trying something, see does it work, try it again, does that work? Okay, thank you. I just wanted to get some key ideas out there.